Lectures we will be learning routing and forwarding. What routing means? Suppose there are multiple paths from source to destinations like this. In that case, to find out, we need to find out the which one is the best one. Then, with the help of algorithms, we'll decide which one is the best one. And other things is forwarding. Suppose this we have a router. So you can see over here. Router is connecting to networks, network 1 and network 2. Router takes a packet from one networks and forward to another networks with the help of forwarding tables. That is the process we call forwarding, right? What are the protocols we use to find out the best route among available routes? There are two categories based of routing protocols. First one is an interior gateway router protocol. Second one is exterior gateway protocols. Under the interior gateway protocol, what interior means? Inside the organizations. If routing is needed inside organizations, then we use the protocols comes under the interior gateway protocol, which is routing information protocols and open source path first protocols and hybrid protocols. In these lectures, I will cover first routing protocols, then open source path first protocols. Then we go ahead to cover exterior gateway protocols. If there is a communication between the organizations, then we use this kind of protocols. The protocol's name comes under this category is BGP, Border Gateway Protocol. So before going to the actual protocols, we need to know some preliminaries about the protocols. Suppose we have RIP protocol, OSPF protocol, BGP protocols. What we will do in with these protocols? Suppose we have a networks. Let's understand what are symbols in these networks. Suppose this is a R1. This is a router. You can see in circles which is crossed with these are the routers, and there are links which is connecting two routers, and associated on each link is a weight. This is the cost. The cost may be bandwidth delay, and each router is connecting other routers via link. How many routers we have in this networks? 1, 2, 3, 4, 5, 6 routers we have, right? Now suppose if we want to find out the shortest path from R1 router to all other routers present in this network, right? This we run any algorithms and from this source and find out the shortest path from R1 to all other routers. Suppose for examples we run algorithms and we got this one. If we want to go from R1 to R4, we need to pay price 5 units. Suppose if we want to go from R1 to R5, then we will pay price 5 plus 1, 6. Similarly, if you want to go from R1 to R4, R2, we get we have to pay 4 price. If you want to go R1 to R3, then we pay price 4 plus 3, 7. This is what the tree we get. This the yellow lines represent the least cost tree for the router R1, right? If we write the forwarding tables corresponding to our routers, we can write with this like this. In this table there are two columns. First one is a path from R1 to all others routers, suppose from R1 to all other. In second column is a corresponding cost. Suppose if we want to go from R1 to R1, we are going from R1 to itself, that is why cost is 0. If we are moving from R1 to R2, then cost is 4, as we can see here in this figure. If you want to go from R1 to R3, the cost is 7. You can follow this path, right? Similarly, for our other routers, we will create the forwarding table for each routers. The best way is the first you find out the least cost tree for each router, and then from least cost tree you create the forwarding table like this, as we have created for router R1. Similarly, you will create this kind of routing tables for all other routers, right? So question is, how do we find this vector? Vector means this is cost vector. We can write this cost vector and like this, right? The question is, how do we find this cost vectors? Definitely we will run routing protocol algorithms. With the help of routing protocol algorithms only we can find out this vector. Thank you.